Hey Algebra 2, today we're going to discuss Chapter 3.2, which is solving linear systems algebraically. So in 3.1 we solved one way, was graphically, and by doing that we just graphed our two lines, we saw where they crossed. Today though we're going to talk about two algebraic ways to solve a linear system, and these are much more precise and will always give you an exact solution. So our first method for the day is the substitution method. Okay, so keeping in mind that you're going to have two equations, you're going to solve one of them for one of the variables, so either x or y in either the first equation or the second equation. You're then going to take this new expression you have from solving one of the equations for one of the variables, and you're going to substitute that expression into the other equation and solve for the remaining variable. And then once we know what one of the variables are, you're going to substitute that known value back into one of the original equations and solve for the other variable. It all makes perfect sense, I'm sure. Alright, what will make more sense is if I actually show you an example. So here's our example, and the one thing you need to keep in mind is that unless otherwise specified, like you are solving by substitution, you want to choose substitution when you have a variable that has a 1 as a coefficient. So here we have a y value that has a -1, which is fine, as a coefficient. And that is when substitution works best. Okay, so your directions. So step number 1 said solve one equation for one variable. I am going to solve the first equation for y. This is going to be step 1. So I'm going to solve it for y. I'm actually going to add y over and subtract the 13. So that cancels. And I'm going to switch it all around and make it y equals 3x minus 13. So there's step number 1. It said solve one equation for one variable. So I solved the first equation for y. Step number 2 said substitute that value into the other equation. Okay, so this is going to be 2x plus 2 instead of y. I now know that y is 3x minus 13. And solve for the remaining variables. So notice now I am down to one variable. All I have is an x. And it happens twice, but that's okay. I have one variable versus two variables. So we need to solve for x. So we're going to distribute and get 6x minus 26. And we'll combine like terms. And we're going to add the 26 to the other side. So I get 8x equals 16. And finish out solving for x. X equals 2. Then the third step was to now take our known value, so this is now our known value, and substitute it into either original equation and solve for the other value. So I want y. Now there's lots of you that probably go, why can't I use this one to solve for y? And you can. But the deal is, though, if you've done something over here wrong, then you're putting it into a wrong equation. That's why I go back to the original, but then too, if you've done that wrong, then you've done this wrong, and, you know, it just kind of went downhill from there. So I'm going to go ahead and substitute it into the first equation. So I'm going to have 3 times 2 minus y equals 13, and I'm solving for y. So subtract 6, negative y equals 7, divide by negative 1, and we get y equals negative 7. Alright, so the one thing that you need to remember when you're done is to bring these back together and make an ordered pair, because this is still the ordered pair where they cross. We just did it without finding it graphically. Alright, and the other thing too is it's always nice to check these. These are really easy to check, so there shouldn't be any time you get these wrong. 3 times 2 is 6. 6 plus 7, because it would be minus a negative 7. 6 plus 7 is 13. And we'd have 4 minus 14, and 4 minus 14 is negative 10. So this works, and this is your answer. The rest of that there is work. So that is substitution. Our other method your book calls linear combinations, and it's also known as elimination, so you can call it either one there. And so its steps, we're going to start by multiplying one or both equations by some constants, so you're going to have to come up with those, to obtain opposite coefficients. So if one of them is a 2x, we want the other one to be a negative 2x. Those would be opposite coefficients. Then you're going to add the two equations together, and when you add opposites, they cancel out. Okay? And you're going to solve for the remaining, we're going to solve the resulting equation, which would be one remaining variable. And the last step is the same last step as the previous one. You're going to substitute back in to the original to get the other variable. So let's take a look at this. So here's our system, and we want to make opposite coefficients. And it doesn't matter which x or y you make opposite. Sometimes one is easier than the other. This time, if you were to make the x's be opposites, they would be 6 and negative 6. You're looking at a least common multiple there. Otherwise, for y's, it would be 6, and all we have to change is one of them. So for x's, we'd have to change both, but for y's, we'd only have to change one. And so you might see that kind of as the simpler route. So to get 2y to be a 6y, I'm going to multiply the second equation by 3. So I'm going to rewrite the first equation. Nothing changes there. But the second equation, I'm going to distribute the 3 to everything, so it's become negative 9x plus 6y equals 30. Okay, so that's your first step, is to multiply by some constant that's going to make opposites. Then your second step was to add them together. So if I add these together, I get negative 7x, those cancel, equals 49. Okay, and then your third, well, sorry, still part of the second step, solve the resulting equation. So if I divide by negative 7, x equals negative 7. And then the third step was to take that and plug it into one of the originals. So we're just going to go into the second one here. Negative 3x times negative 3 times negative 7 plus 2y equals 10, and solve this for y. Equals negative 11. So I get y equals negative 11 halves. And that's something that's much more exact than what you would get solving it graphically. So do keep in mind we still need to write our answer as an ordered pair. Okay, and if we go ahead and we check our answer, let's see here. So 2 times negative 7 would be negative 14. And this is going to be a positive 30. And our other one would be positive 21. And then this would end up being minus 11, and 21 minus 11 is 10. There you go. Let me know if you have any questions, and I'll see you in class.